Welcome to the project demonstration of automatic fire detection system by using LM358 Comparator. So here we are using the comparator instead of using embedded C language or microcontroller. So we are using directly comparator, which is non-microcontroller based. So here this particular LM358 IC consists of two comparator inputs and outputs. So that is 1, 2, 3 are the one comparator, and 5, 6, 7 are the another comparator. So in that, first pin number 1 is the outputs, 2 is the inverting inputs, and 3 is the non-inverting inputs. So the main difference between the inverting and non-inverting input is, so based on the consider pin number non-inverting input voltage is going to be the V non-inverting and V inverting. So whenever the V inverting is greater than the V non-inverting, then automatically the output at the pin number 1 is 0. I am repeating that. Consider V1, V2, V3. So V2 is the non-inverting inputs. V2 is the inverting inputs. V3 is the non-inverting inputs. So whenever V2 is less than the V3, then automatically the output is high. V1 is high. High nothing but whatever the input voltage is, will get the same output voltage at the pin number 1. So if the V2 is greater than the V3, then the output is 0 volts. So this LED will show the status of output indication. So we set this potentiometer as a threshold value. Whenever the flame detects, it will provide us a 0. Then here we connected the flame sensor outputs to the pin number 2 and potentiometer output to pin number 3. So whenever it will get the fire detection, then it will provide the 0. So then automatically V2 is going to be the less than the V3, then the output is high, then this red LED on and buzzer also will get switched on. So this buzzer board consists of a transistor BC547 transistor. It will get the triggers from this LM358 IC. So this particular adapter will take the 230 volts AC input and provide us a 5 volts DC constant output. So let us see the demonstration. So once we switch on the gauge, there is a one light indication on this fire sensor. Another light will be on whenever it will detect the flame. So as we know that the flame consists of IRs. So for demonstration purpose, we are using this flame sensor which is detected on the IRs. So in real time, we are going to use based on the application, we will use the image processing for high accuracy. So we can see one light gets switched on the flame sensor, red light on the comparator board, and buzzer will get switched on. So the 3 will switch on at a time. So when we show the fire in front of this flame sensor, it will provide us the 0 volts. Till that, it will provide the 5 volts. So no flame, 5 volts, flame, 0 volts. So this input to the V2. So as we discussed, if the V2 is less than the V3, then the output is high. So when we show that it's not less than the V3, then output will be the high.